Hi guys, so today we will be adding, subtracting, and multiplying radicals. So these are the rules that are mentioned that what we have to do. I'm not going to read it for you. You can read it or you can read it yourself. I'm going to go over through half of the problems on the front and the back. And the whole thing is due on Tuesday. And then this homework page will be due on the next day, on Wednesday. So let's go ahead and solve the problems. So this is problem number 1, 3 square root of 27 minus 2 square root of 12. So it looks like we have different radicands. So 27 is different from 12. But you might be surprised by after you simplify this, you're going to have the same radicands. Okay, so that's what we're going to do. We're going to simplify. So 27 is actually 9 times 3. And then 12 is 4 times 3. So what we did, we factored 27, and one of the factors is a perfect square. The other one is not. 12 is 4 times 3. 4 is the perfect square. So this is the next step. Now we're going to put those two numbers under different radical signs, and then we can take the square root of 9 and then square root of 4 and multiply it by 3. So 3 times square root of 9 is 3. 3 times 3 is 9. Square root of 3 minus 2 times, this is 2 as well. 2 times 2 is 4. 4 square root of 3. And now we see that we have the same radicands. And we behave the same way as if we, instead of square root of 3, it would be x. So 9x minus 4x. Would we be able to subtract with, in this case? Yes, we would. 9 minus 4 is 5 square root of 3. And this is the final number, the final answer. Okay, number 3. 7, okay, 8 minus 2, 3 plus 3. Okay, so we are dealing with fourth and third degree roots, okay, cube root and fourth degree root, okay? So we have to understand that these are the same and this is different. Why? Because this is a cube and this is fourth degree. So now what we're going to do, we're going to factor out the 48. So that's what we're going to have. It's a fourth degree root of 16 times fourth degree root of 3 minus 2 fourth degree root of 3 plus 3 cube root of 72. Okay, we're going to split the 72 a little bit later in the next step because I just didn't do it now. How about we do? I'm going to do it now. So I'm going to get rid of the 72. And it's 8 times 9. Fourth degree root of 16 is 2. Because 2 times 2 is 4, times 2 is 8, times 2 is 16. So the whole thing is 2. So 7 times this 2 is 14. 14, fourth degree root of 3 minus 2, fourth degree root of 3. And then I can take a cube root of 8, it's 2. 3 times this 2 is 6. Cube root of 9. These are like terms. 14 minus 2 is 12. 12 fourth degree root of 3 plus 6 cube root of 9. So this is the answer for number 3. Number 5. Square root of 98x to the fourth power y to the second power minus 3x squared y square root of 2. So we can factor 98. 98 is actually 49 times 2. And 42 is my perfect square. x to the fourth power y to the second power minus 3x squared y square root of 2. We just copy this. And then square root of 49 is 7. Square root of x to the fourth power, we're going to take, okay, that's what we're going to do. I'm going to do it on the side, okay? If you had square root of x to the fourth power, how would you take the square root of this? That's what you're going to do. You're going to put x, this 4 goes on top, 4 on top, and this invisible 2 goes on the bottom of the fraction of the power. Okay? So it's 4 over 2 is actually 2. So it's x squared. So the square root of x to the fourth power is actually x squared per right here. So it's always, you'd put the power on top and the index on the bottom. And then you figure out what it is, and then this is your answer. This is the power for your variable. So the same thing, y to the power 2 over 2 is just y. And then what's left inside is 2. Because we took the square root of this, square root of this, square root of this, and then the 2 was left, so it still stays under. Minus 3x squared y square root of 2. So we see that the radicals are the same, they have the same indexes, and there's the same radicands under the radical sign. So we can just subtract them. 7x squared y minus 3x squared y is 4x squared y, and then we just have to put this square root of 2. Okay, problem number 7. Square root of 27 times square root of 5. First, we are going to multiply 27 times 5. We cannot take a square root of 27, cannot take the square root of 5. So what we can do, we are going to multiply them. 27 times 5 is 135. 135 can be factored as, one of them has to be a perfect square, and the other one, whatever it is. So it's 9 times 15. The 9 is the perfect square. Square root of 9 is 3, square root of 15. Number 9. 2 cube root of 9 times 5 square root of 3, and then negative 4 is inside. So we cannot take a cube root of 9. We would be able to take the square root of 9, but there's no way to take the cube root of 9. We cannot take the cube root of negative 24. So what we're going to do, we're going to multiply the outside numbers. 2 times 5 is 10. And then we're going to multiply the inside numbers. But mind you, as long as you have the same indexes, if there was 3 and 2 right here, you cannot multiply these numbers inside. But since they are the same, yes, you can do that. So the cube root of 9 times negative 24, and that is negative 216. So the cube root of negative 216 is negative 6. Because negative 6 times negative 6 times negative 6 is negative 216. So times negative 6. And the answer is negative 60. I'm going to continue in the next video.